can I have a quick show of hands? So who of you has tried to find where a piece of code was slow that one time? Okay, for which one of you guys did it take longer to actually find the place where it was slow than to fix it? No, yeah, so this is the talk for you, great, you're all in the right place. I'm going to give you superpowers. I do not have my wizard hat, but there will be magic. Also, yes, because I do computer science stuff, I'm also terrible with names, so that was the first title of the talk. That was the second title of the talk. That was the third title of the talk. I'm not sure which one I like the best. We'll get there. Maybe we'll have a vote later. So I work at Sorceress. We do machine learning stuff with people. That doesn't matter. What matters is how we do it and what our system looks like. This is what our system looks like. I mean, originally this was about Google Brain, but no, really, it's the same thing, just slightly different labels. My point is, systems are complex. Systems get complex really hard, really fast, and it's really hard to know when they go wrong. And in fact, when a system goes slow, it's kind of the worst place to be in, because if a system doesn't work at all, you have a place to start with. If a system is just slow, it's, where do I go? What do I do? Well, I have an answer for you, and we're actually going to start with a demo because I'm going to show my hand a little bit, but don't worry, there will be another magic trick later. So, let me show you a very simple Django app, a very humble Django app, which you can probably not see, but that doesn't matter. I'll make it slightly bigger. So what this does, when I hit this endpoint, it fires one of the Python benchmarks. And like so, it has taken us, yeah, 4.44 seconds. Yeah, great. A benchmark and a Python. Who cares, right? Yeah, I'm going to show you one more thing. No, don't worry. Oh yeah, this is the admin page. Yeah, let's load that. Okay, why did we do this? Oh, we did this because there's another page in here. There's a page in here that profiles every single request I make to the server. And in fact, it does it for free. Almost free, we'll get to that. There are actually real numbers. But so, for example, let's see what happens when I went to admin. Oh, it did a lot of stuff. It had wrapper, wrapped views, reverse. Oh, wait. Then there's some native symbols. Okay, let's click on this thing. Oh yeah, Python GC malloc. Oh cool. So not only does it profile all the requests that you make, it actually goes to the C level for when you have the symbols. For Python, you actually usually do. Yeah, and yeah, this is still free. And let's take a quick look. Because yeah, this is a normal. The fact is, Django requests they never look pretty. That's why this thing, when you click on it, oh, actually, by the way, I stole this profiler thing. Don't worry, I will tell you where I stole it from. And for example, we have a different thing which calls just Python's view. See that native symbol here? Oh, that's sleep. Sleep is not actually a normal Python function, but if you profile down to the C level, yeah, you will see sleep. If you have a debugging build of Python, you will actually see it's called sleep. But yeah, I mean, hopefully by now you have gotten an appreciation of what profilers are. Profilers make graphs like that. And that's how you get to know what happened every time you did, because you just look back. There's no reason to figure it out if you already know. And with that in mind, let's actually begin. Oh, sorry. The essential questions for profiling is like, okay, why would you do this? What do you profile? When do you profile it? How do you do that? And I will quickly show you the difference between tracing profilers, which is, for example, what C profile is, versus statistical profilers, which is what VMProf is. VMProf is the thing that we use for our magic today. So why would we do this? A number of reasons. Like, for example, performance matters. Like, I don't know, for instance, yeah, I write in Python, but yeah, performance matters. You don't want to waste time. However, when I say you should spend your time efficiently, I mean developer time, as in the time it takes you to, actually make stuff, and also the time that you actually are spending on the CPU, because that tends to matter as well, right? And the main issue with performance bottlenecks is yeah, it's obvious once you know how. It's obvious once you've seen it, but trying to define in advance where your application is going to get slow, in practice is an exercise in futility. Why? Because well, usually it's not your code. Usually it's 7 layers deep, someone else's code that called a library, that called a library, that called another library, that slept for 60 seconds because it had a bug. Or tried to talk to a TCP socket and actually broke it in a way that made it hang for 2 hours. We've actually seen this in production. Sentry is great when it works. When it doesn't, it makes your life miserable. Oh yeah, so this is an artistic depiction of actually fixing performance bugs. It's like basically, yes, your system starts off really nice because it's super small, yeah, and then it grows, it grows fangs. All of a sudden you know what you do. What to do then is to turn to the two saints of profiling. There's Donald Knuth and Alistair Moody. Why are those guys the two saints of profiling? Because the first one said we should forget about small efficiencies and premature optimization is the role of evil. The other said the very important thing, constant vigilance. Constant, yes, always. You always want to be looking. The moment you back away, your system will sink its teeth into you. However, the Don Knuth quote gets slightly misinterpreted a lot because he was specifically saying you should ignore small inefficiencies, you should avoid premature optimization. Alistair Moody, well, constant vigilance. That's it. That's what I really expected to do. That's what I'm trying to get you all to be able to do. Because now we have the technology. And okay, so what do you profile? Well, all the code that matters. For example, if you have a Django app, like all the Django setup is probably not interesting. You want to actually start profiling as the very last middleware you're doing and finish profiling as the very first middleware you're doing because that will only capture your code. Like if Django is slow, you're kind of in hell, but yeah, like usually like 97% of the time that is not your problem. So yes, this is like the demo that I gave you was for Django apps. This is also useful for any system that like performs a bunch of tasks in sequence because then every task is a self-contained thing, every task you can profile and every profile you can save so that you can look at it later. So for servers of any kind, when a request starts, you enable the profiler. When a request ends, you stop the profiler. Simple, right? The one thing is profilers fundamentally break when you introduce threads. I'm making some headway to make VMProf, which is the thing we're using, to kind of work with multiple threads, requests being profiled at the same time, but the short answer is do not do this. Only one profiler can be active per process, that's it. So yeah, please, multiprocessing is a friend. Multiprocessing is great. Use multiprocessing, guys. Please, I beg of you. Use it every chance you get. If you're trying to profile like desktop applications with Python, I don't know. I have written a WX application in Python that was 7 years ago. I don't know. If you would like to do something like this, if you know how, talk to me, make a question, because I would like to know how else this could be used. So when do you do this? Alistair Moody told us all the time. Unless you have a time machine. If you have a time machine, actually it would be super cool because you could just go back in time and say, oh yeah, that request I should have profiled. So I'm going to give you a time machine, and you know, the time machine is like just, yeah, let's do it all the time. And not look at it most of the time. Because the thing is, like, this is not your first line of defense. If something is slow in your system, you should have other things that alert you to the fact that it's slow. You should have Prometheus, something else, like you should be monitoring your request time. This thing is only after you've discovered something was slow to figure out, okay, how did it get slow? And so with that in mind, you should be totally comfortable with the fact that this is not a thing you will use every day. I mean, God help you if you need to use this every day. This is a thing that, yeah, once a week, just like shit. And then, like, yeah, it was there. It was always there. It was always watching your back. And that's it. Ideally, you will not remember it's there. I usually don't remember it's there. And an embarrassing number of times I have actually tried to do the shitty way of profiling. Then I remembered, oh wait, I solved this. Jesus Christ, I solved this. Why am I doing? So yes. If you do implement something like that, make sure to remember it's there. One thing to watch out for: you should set your system up such that if something times out, it still saves the profile. We at Sources, like we do machine learning stuff, so we have an incredible amount of tasks, some of which can take up to 6 hours. And then some of them take 6 hours and actually fail because that was not enough. When we first rolled this out, well, that was an exception, right? Because yeah, you timed out and then it died, and then I didn't know what it was doing at that time that it died. So don't repeat my mistakes, guys. Just you have the technology now. It's great. So how does this thing actually work? Well, there's two types of profilers. There's tracing profilers, which like are actually helped by Python a lot, and there's statistical profilers. Tracing profilers are like kind of simple-ish to implement. C profile is a type of this, except it's implemented at a slightly lower level, but it works basically the same way. So you call sys set profile, and then you pass it a function. That's your profiling function. Every time Python enters a new function, it calls your thing. It says, hey, here's a stack frame. Here's an event. The event is usually, oh, hey, I started a function. And then when it leaves that function, it says, hey, it's me again. I'm leaving. So yeah, you get called whenever the Python interpreter starts a function, when it leaves. And so there's two pitfalls here. One, which you should be immediately suspicious. Wait, every time I call a function, getOther is a function. setOther is a function. Every time I do dot something, that's a function. Yeah, every time, every single time. That's why this is expensive. That's why you could not do it. I mean, I would love to be able to do this all the time, but no, this is just too expensive to be having on at all times. Also, there's a slight pitfall here is like the moment you call a C function, it goes into a black hole. When it is done with the C function, yeah, it will tell you what left. But what it was doing, what was there, I don't know, that's outside of the scope, which, yes, that's why we have better technology. Statistical profilers are slightly different. They also have a function that gets called every now and then, but basically what you do is like, okay, call me 100 times a second, or call me 1,000 times a second. And then what that function does is like, okay, I'm going to do my own thing, figure out where your Python code is, where are its stack frames, what is it doing, and I'm going to do something with it. And when I'm done, yeah, you get the GIL back, you get the control back. And yeah, then ideally you would save it somewhere. The thing is, so you could do this in Python, actually. You could do this in Python. There's some slight pitfalls, which I will show you in a second, because we are, I think, oh no, sorry. We're almost to my next magic trick. So yes, tracing profilers, they see every function call. There's overhead. They inherently can't work with multiple Python threads because they get called always by the main thread. So you cannot call like thread get ident or whatever the thing is named. No, and Python doesn't tell you where it switched threads. So no, you know a function was called by this process. That's all you get to know. If you want to keep track of line numbers, like okay, which line of the function were we on? That's even worse, because then you need to use setTrace. setTrace is like setProfile, except it gets called even more, and it's even more expensive. And in short, don't do this to yourself. Statistical profilers, they're not ideal. Nothing is ideal in this world. They see only a fraction of the stack frames, because yeah, like if you call me 100 times a second, we will see 1/100th of the code that you executed. But actually, it turns out in practice, it's good enough. They are low overhead, well, unless you implement them in pure Python in 30 seconds, which is what we're going to do in a while. And they can sample multiple threads. Here's the thing, they can, VMProf, the thing we're using, VMProf actually saves thread information and then proceeds to do nothing useful with it. If you need that, call me. I would love to help you, but I don't. So I just multiprocessing, guys, really. Trust me. And yeah, for them, keeping track of line numbers is actually almost free. And the problem is like, yeah, writing a correct thing of this sort is it's a challenge. So, but let's see how we could do this on the quick, right? So, yeah, this is our proof of concept profiler. Let's see. We can't have that, right? That would be cheating. Okay, yeah, sure. Oh yeah, I'm using cat because like I don't want to get into the V versus MX things. Like just, guys, no, really, like just. Okay. Oh, so sorry. Yeah, we actually do want to have a NumPy. Okay. 1 and 2 and 3. Don't worry, guys. Almost there. Almost there. Almost there. I just yeah. I forgot this. Oh yeah. Yeah, 20 seconds. Great. Okay. So, okay, what did this actually do? Let me show you. So we have a timer thing. The timer thing is basically, okay, when it calls this function, we'll tell you how long did it spend in real actual time. It will actually measure. That's not what we're normally doing, but we want a paint of comparison. We have two types of work. We have, just like a washing machine, there's like a spinner, there's a faster spin, and then we wait for a little bit. The spin loop, self-explanatory, for y in range, just return the sum. The other thing is a more Pythonic, faster way of doing these things, which will actually show you how these things break if you try to do them in real Python. And yeah, then we just wait a little bit. How a profiler works is like, okay, there's a threading event because I said no threads. I wanted to give you something that you could actually run in your own. This is on my GitHub, by the way. So this will also work on Windows. All the real ways of doing this will not work on Windows, so that's where we're at. And it has an event. That event that basically tells the provider, hey, we're done, your services are no longer needed, please remove yourself from the premises. And how do you do profiling? I'm glad you asked, because this is actually very simple. Because CPython is awesome, and also like Python is awesome. The only thing it does, okay, this spins in a loop on its own thread, except not really. Here we have a magic thing which says, okay, wait on this event. And the sampling interval is to tell you, okay, how often should this fire? So basically, in effect, it will just fire, well, what I set it to, 100 times a second. It will actually do stuff. Other times, it will just wait for this thing. And there's a wonderful little thing called sys_get_current_frames. This gives you the current frame for all the threads. So yeah, that's why this is like slightly better, because yeah, if you have mapped your threads, so then what you could do is, for example, don't profile yourself, because that's stupid, really. And then what you do, okay, so we have this wonderful traceback module, which is like, okay, just like extract this track, and then of course we want the to order the stack slightly differently, because the stack is sort of like from the oldest to newest. You want it to go the other way, you will see why in a second. And then we have two things. We have a samples counter, which tells you, okay, how many times have I seen this particular function? And a seconds counter, which says you, okay, how much time did I roughly spend in there? Why roughly? We will see in a second. And yeah, and then you're done. We'll just print it. So let's just run it. It's probably easier. Oh yeah. That's what happens when you make a new file. Okay, so we spin for a little bit, we spin faster. Okay, so here's what our profiler did. It's like, okay, it estimates half a second here. And you notice, oh yeah, wait, this is 1 second, this is half and half. Oh, yeah, because this is in two different lines of the same function. So remember how those lines were free? Yeah, they are. So yeah, because the first function line 30 and 31 are this thing. Line 30 is us just being here, and line 31 is us being here. Yeah, it kind of makes sense that it's half and half. And then, okay, then it went to the second one. And then work spin fast. It's like, okay, 1 second here. That's true, but it said that's based on one sample? Wait, what the hell is it here? Well, okay, we should have roughly one sample per every, like we should have 100 samples a second, right? So no, when we wait, we do. When we run code, we don't. When we run other code, we get one sample. No, this must be wrong. Let's run this again. Oh, now it disappeared. Now we're waiting two times. So this points to a fundamental limitation in doing things in pure Python. Pure Python, whenever you're executing C code or any extension code or anything else of that sort is happening, you cannot switch threads. You also can't respond to signals. There's nothing you can do. You need to just politely wait to exit from this black hole that is native code. And why would this innocuous little function be behaving like this? I'm glad you didn't ask, because I'm going to tell you anyway. If you disassemble this function, it does, okay, it loads sum, loads range, loads size, and then it calls two functions. So yes, it was actually spending all that time doing one of those functions here, and you had no chance of detecting it, no chance in hell. That's why we don't do things this way. So, knowing that, I mean, yeah, I would love to have a pure Python profile. That would be great. Nope. So what would you want? What would you want from a system that we're going to actually use every day? ideally, of course, low overhead, near constant sampling rate, because this thing was not actually sampling at a constant rate. Some way of saving profile data, some interface that's better than text. Well, we've seen that. That's actually there. Yes, you should always enable it when you're doing something. You should be able to record line numbers. We were. And yeah, it should also just be able to look into native code, which we were. Isn't that great? Isn't that handy? So yes, actually I'm here to tell you, yes, we have found the holy grail, and the name is VMProf. VMProf was a thing that was originally made, as the name suggests, to profile virtual machines, more specifically implementations of Python. So the problem with VMProf was that it's actually written in C. It's written in, very gnarly C. It does set a bunch of signal handlers, except not at the level of Python, no. At the age-old level of C, it will preempt Python doing anything with them. It will actually walk the stack trace for Python itself. Yeah, going through all the stack frames, all everything, going down to C code if it needs to. Yeah, it can do that because it's fast. It's written in C. It's great. I mean, it's great to use. The problem with that was that since it was made for profiling virtual machines, basically mostly CPython versus PyBay. I think that's the only thing that was actually used for. So it had no concept of, let's actually measure real time now. That had to be added. That's where I came in. I'm a wiser, weaker man now. But yeah, you can use this now. So you might ask me, hey Bartosz, cool, yeah, but how much does this actually cost? Nothing is free. Yeah, okay. I lied a little bit. It's not actually free. So yeah, it costs 2% overhead if you sample 1,000 times per second. By the way, you do not need to sample 1,000 times per second. If your code switches functions that often, you have other problems. Also, let's now mention one thing real quick. So, as we've seen here, you actually get the whole stack trace. So you do not only know, okay, I was in this function. You also know, oh yeah, but also I was in this wrapper. I was also in this work thing. So even if it's not super accurate at the lowest level function that's possible, yeah, if you go 2 levels up, you will know what's up. So don't worry about it. It's great. So yeah, how much data does it produce? Yeah, around 2 megabytes per minute, which seems like a lot, right? So yeah, but if you compress it, that shrinks to 2% of the size. So actually, it's 2 megabytes per hour. If you can spare 2 megabytes per hour, I suggest you get a bigger machine. Because guys, this is free. Just trust me. This is free, right? So yeah. So to close it off, because guys, just check out my GitHub. I just hope you will use this because it changed my life. My feet don't even smell. I lost 20 pounds. Just my life is great. So yeah, just a couple of things to keep in mind. Your code should be fast enough, but guys, don't go overboard with this. It's very easy to go overboard when you can look everywhere. The most important skill is knowing when to stop. When you actually try to fix something with this, move up the stack as much as possible. That is to say, you have this one method that is slightly slow, and your first instinct might be to okay, let's make this method really fast. No. The best fix to slow code is not to run it at all, or change the way that it's being run. There's very few cases where small optimizations, small benchmarks will get you much of anything. So please resist the urge to micro-optimize. And so some examples that we actually caught with this. Remember I said it's always other people's code? So yeah, the first one is what we had. So we had a thing that was saying, okay, we have all the data, which is oh my God, what has happened? We have all the data, which is a bunch of strings, and we have a list of words, all the words ever, in fact. And yeah, somebody decided, yeah, let's go over all the words and then over all the string.count. Yeah, that's fine, right? No, because we started getting more data and all the data. One time, one day it just suddenly exploded. How you fix that is not to, by the way, invent a faster .count. No, there's a thing called ahau-karasik. There's just you give it a list of words and a list of strings and searches through them super fast. You replace the algorithm, is what I'm saying. Yeah, you can get stuck in a TCP black hole for 2 hours, which is how 1 over 6 hour task time actually timed out. I couldn't believe it. Yeah, that is what happened because this happened for multiple things, and we later, when we stuck a try except loop around that very thing, it went away. So like, I was all ready to believe it was just a profiler going wonky. No, that can happen to you. Oh, caches are great, except that one time we forgot kind of to preload the cache, and then all the first requests, since they had no cache, they all simultaneously tried to fill the cache, which made everything die. Oh, and guys, just if you are thinking about using pandas for ML stuff, don't. And that's what I have. Like, I will also want to tell you that, like, again, that is a thing you can barely see, and that was by design. So Donald Knuth said one very wise thing, which is to say, if you optimize everything, you will always be unhappy. That's why, I work on a galactic scale now. I don't optimize all the code all the time because, like, ultimately, you need to respect your own time. You have your performance envelope, pick it, stick to it. Once you're there, you're done. And that's it. Questions?
We have time for a couple of questions.
Thank you for the great talk. I'm wondering, as you emit or record these logs in a safe place on every function call, how do you, as a human, go back to be like, this is like the trace or the profile dump of that one call that timed out 2 hours ago that I'm working
okay,
on.
so what I have shown you here, right? What I have shown you, in fact, what I have shown you here. Yeah, so no, this is not how it actually looks for us on production. No, we have a much prettier interface, but it's also very intertwined with our own code. What we have, in fact, is like a thing that basically sorts all the requests by time, then figures out which took longer than it expected it to, and then it's like, okay, here's the top 5 things that you may want to look at. So that's how we do it. But for the demo, just like, yeah, I could not be bothered to rip it all out.
All right. So thank you, Bartosz, for the awesome talk.
Thank you.